All right, it is time to go through the January 2023 Regents Chemistry exam. All right, so here are the directions you see on the front of the exam booklet. Here is part A. These are typically the most straightforward multiple choice questions. You will have a copy of the reference tables. So right here, again, the 2011 edition of the reference tables. All right, so when we get to these questions, these should be the most relatively straightforward questions, should not be multi-step. All right, so which conclusion was developed as a result of the gold foil experiment? Well, let's see. Do you remember what occurred in the gold foil experiment? So let me just try and draw a little sketch here. So we had gold foil with atoms, right? And then alpha particles were directed at the gold foil. And what happened is most of the alpha particles passed directly through the gold foil. Some bounced almost completely back, and some were deflected at other angles. But again, most right here passed directly through the gold foil. So what was that evidence of? That right here, atoms are mostly empty space. What did it also show? That atoms have a dense, positively charged nucleus. But that's not one of the options here, so the option that is correct is number 1. Which two particles each have a mass approximately equal to 1 atomic mass unit? Well, atomic mass unit, remember, has the symbol U. What if you didn't remember that? Okay, reference table. So right here, we have U, atomic mass unit. I'm looking for another table, which is going to be right here. Table O. All right, and I need a mass approximately 1. Well, what you need to remember, let's just zoom in a little bit on this table. What you need to remember about this table is that the top number is mass and the bottom number is charge or atomic number. And if it is the atomic number, it is the charge of the nucleus. So it's not like there's all the elements listed. These are just the nuclear symbols. So I'm looking for mass of 1. So I need this top number to be 1. And I see that here, and I see that here. So I have neutron and proton. Okay, so the answer really is in the reference table. You just have to go and look for it. An excited potassium atom emits a specific amount of energy when one of its electrons moves from. Okay, so what you need to remember for this, right? So we have a small, dense, positively charged nucleus, and then we have electron shells around the nucleus, right? Where we have orbitals. And when energy is emitted, emit means to give off, an electron will fall from a higher energy level back down to a lower energy level. So it was in excited state and it falls back down to ground state. All right, so let's look at our answer choices. From first to fourth, well, that's going up. Second to fourth, that's going up. Fourth to fifth, that's going up. Fourth to second, aha, that is going down. That is going to be our answer right here, where energy is going to be released or emitted. But also, fun fact I'd like to point out for this question is that you can play the one of these things is not like the others. If 3 of these have an increase and 1 has a decrease in, where it's going in the energy levels, should be obvious which one is the answer. Which list of elements includes a metal, a metalloid, and a noble gas? Well, we need the periodic table. So let's get to the periodic table. Here we go. So metals over here, left side, except for hydrogen, that's a nonmetal, are metalloids right here. Along the staircase, right, on either side. So it would be easy to identify a metalloid first. So let's go back to our list, and I know for sure that silicone, right? Silicone right here is a metalloid. Now let's see. I know that noble gas, I need a noble gas, right? So let's check. I know those two for sure have a metalloid. Now let's look at noble gases. Noble gases is group 18. So helium, neon, argon, krypton, xenon, radon. So let's go back and see if any of the ones I already selected. Well, this does not have a noble gas, so that's wrong. Ooh, but look right here, radon. That is a noble gas, right? So if this is a metal, that's my answer. So strontium, where is it? Right here. It is an alkaline earth metal in group 2. So the correct answer is number 2. All right. Which element has the lowest density at 298 K and 101.3 kPa? It's just a reference table question. So I just need to go to table S. And I have argon, fluorine, nitrogen, and oxygen. All right, let's zoom in a little bit. So what do I have? And again, density is, see this column right here. So I have nitrogen, oxygen, argon, and fluorine. So nitrogen, oxygen, fluorine, and argon. So which one has the lowest density? So I need to look at which number is the smallest. Well, they all have 0.00, right? So they all have 1 for the next number. And then I look here, and nitrogen has the smallest. It has a 1 in this place. So that makes it have the smallest density. So that is nitrogen. All right. Oops. Which phrase describes the crystal lattice and properties of 2 different forms of solid carbon called diamond and graphite? Well, that's a word called allotropes. And this relates structure and properties. So here's the deal with structure and properties. If they have the same structure, they have the same properties. If they have a different structure, they have different properties. Structure determines function, if you remember from lots of other science classes. So right here, different structures and different properties. Which element has chemical properties most similar to sodium? Well, sodium is Na, so let's go to the periodic table. And if it has chemical properties most similar, it is going to be in the same group because elements with the same number of valence electrons have similar properties. So which one of these elements is in the same group as sodium? Right here, rubidium. Oops, not oxygen. Highlighted badly. Rubidium. Oh, I guess I will just underline this. There we go. This one didn't want to go. Which substance contains elements chemically combined in a fixed proportion? Well, if they're chemically combined, that identifies a compound. So let's look. Oh, element, element, element. This is, again, one of these things is not like the others. There's the compound. Which property can be used to differentiate between a 50-gram sample of solid potassium nitrate at STP and a 50-gram sample of solid silver chloride at STP? Well, they have the same mass. Get rid of it. They are both solids. Phase, can't use that, right? They're both at STP, which means they're at the same temperature and same pressure. So the only thing I could use to differentiate them according to this list is solubility. Which type of bond forms when electrons are equally shared? Okay, so first of all, sharing is covalent, right? So I'm at a 50-50 chance. Equally shared is non-polar. So number 2. Which statement describes the changes in bonding and energy that occur when a molecule of iodine, I2, forms two separate atoms of iodine? Okay, so we have I2, right, forming two separate atoms of iodine. So that is definitely breaking a bond. So eliminate these two. I'm at a 50-50 chance. And in order to break something, that takes some energy, so energy is absorbed. All right, the degree of polarity in the bond between a hydrogen atom and an oxygen atom in a molecule of water can be assessed using the differences in electronegativities. You should just know that. Which substance cannot be broken down by a chemical change? Which one is an element? Krypton. Which sample of matter is a mixture? So what I'm looking at are the indications right here. And the one that is a mixture is right here. Why? Because it is magnesium chloride dissolved in water. So it's not just magnesium chloride. Which term is used to express the concentration of an aqueous solution? Well, if you weren't sure, if you didn't know it right off the top of your head, which can happen also in a panic on the exam, go to the selected units in Table D, find concentration, and you can see there are two options. So it is parts per million. The particles in which sample have the lowest average kinetic energy. This question is always here in some way. They're going to test if you know. Do you know that temperature is average kinetic energy? And I'm just looking for the lowest temperature. So do I care how many grams it is? No, no, no. All I'm looking for, lowest temperature. So it's right here. 273 is the lowest. Which process represents a chemical change? Well, sublimes, sublimation, that is solid to gas, starts as a solid because sublimation starts as an S. That is physical, evaporation physical, melting physical. Oh, there we go, chemical change, burning. Okay. Which equation represents a physical equilibrium? So first of all, equilibrium requires an arrow that goes in both directions. So I can eliminate this and I can eliminate this, okay? So if it is a physical equilibrium, it means I have the same exact chemical formulas on both sides of the equation. So look here, N2 and N2, so that's physical. The other one is chemical because the chemical formulas change on both sides. Systems in nature tend to undergo changes toward, well, this is like everyone in existence, less energy and get more disordered. Entropy is disorder. Which formula represents a hydrocarbon? Well, a hydrocarbon has only carbon and hydrogen. We have ones, has oxygen right here. This has oxygen and this has chlorine. Which statement describes the bonding in an alkyne? All right, so if you don't remember, use the reference tables, and you're going to want to go to table Q. So in an alkyne, look at the picture. Look what kind of bond you have. So there is at least one carbon-carbon triple bond. Okay. And which compound has a functional group that contains two oxygen atoms? So this is the very next table where we have organic functional groups in table R. And let's scroll down and see we have two options where there are two oxygen atoms. We have organic acids and we have esters. So it ends in something enoic acid or something with a YL and then an enoate. So what are our options here? Oh, right here, methylpropanoate. Which term identifies a type of organic reaction? Well, the type of organic reactions are represented by this, PS faces. So I'll just rattle them off. Polymerization, saponification, fermentation, addition, combustion, esterification, and substitution. So which one is one that I said? Polymerization. In an electrochemical cell, oxidation occurs at the, well, remember there are a bunch of phrases, and one is ox, or red cat. So oxidation is at the anode. All right, which energy conversion occurs in an operating electrolytic cell? What I like to say is electrolytic starts with electro, so it begins with electrical energy. And it converts it into stored chemical energy, not nuclear energy. So the opposite type of cell, which would be voltaic or galvanic, does the opposite, chemical to electrical. But for this one, we have this answer. One acid-base theory. Okay, as soon as it says one acid-base theory and it doesn't say Arrhenius, we're talking about Bronsted-Lowry. And in the Bronsted-Lowry theory, acids are giving away H pluses, so bases are accepting. All right. The acidity or alkalinity of a solution, remember alkaline means base, is pH. When the nucleus of an atom of neon decays, which particle is emitted? Okay, straight reference table question. So I need to go to table N. Oops. And in table N, I need to find neon 19. Here we go. This is the particle. Go to table O. So my answer is a positron, but if you I can represent it one of these two ways. So it is going to be right here. All right, sorry about all that. Allergies are literally kicking my butt. So anyway, let's move on. Which nuclear emission has the greatest mass? Well, this is, again, a straight up reference table question. It is table O. Remember, mass is the top number and charge, or the atomic number, which indicates nuclear charge, is the bottom number. So the greatest mass would be alpha particle. Is alpha particle one of the options? It sure is. Which statement describes the net change that occurs during nuclear fission? Well, nuclear reactions are unique in that mass is converted to energy. So you should just remember that. Mass converted to energy in a nuclear reaction. All right, we're moving on to part B1, and these are also multiple choice questions, but these might be a little bit more complex, okay? So it might be multi-step, a little bit more involved. What is the net charge of a monatomic ion that has 15 protons? Well, protons have a positive charge. Neutrons, no charge. They don't count. Electrons, negative. So if I have 15 positives and 18 negatives, I have a -3. The table below shows the atomic masses and natural abundances of the two naturally occurring isotopes of rhenium. Which numerical setup can be used to calculate the atomic mass of rhenium? All right, so one important thing is we have to recognize that this is a percent. So I'm going to have to divide by 100. And this, first of all, this is ridiculous, dividing by 2. That is the way you determine average when you're not worrying about percentages for this question. So I have to account for a percent. So I'm going to have to divide by 100. What I can do is multiply this number times this number and then divide by 100. And multiply this number times this number, divide by 100, and then add them together. Or I can convert this to a decimal by moving the decimal over 2 places, the decimal point. And that is exactly what was done here. So again, remember, in order to do math with percents, I have to do the divided by 100 part. All right, and let's see. which general trend is observed as the elements in period 2 are considered from left to right? Okay, so these answers, okay, especially for 2 through 4, are going to be in table S. But let's just look at the periodic table first, so you can see why the first one doesn't even matter. So here is period 2, periods go across. You can see that the atomic mass, as I move this way, is increasing. So I know that this first one is absolutely wrong. So I need to check melting point, electronegativity, and first ionization energy. So my first element in period 2 is lithium. So let's go here. My first element, right, is lithium. And I was looking at first ionization energy, electronegativity, and melting point. All right, so let's watch. What is happening to first ionization energy? Going up. Nope. What is happening to electronegativity? Going up. Oh, yes. Let's look at that. That looks like it. Let's just check the last one, which is for melting point. Let's just make sure that is in fact wrong. So what's happening to melting point? Well, it goes up, and well, then it's like way lower. So it's definitely not increasing all the way across. So there we go. All right, which formula represents chromium 3 oxide? Well, I don't have to look up the symbol for chromium because all of the answer choices have it. So I know it's Cr. This Roman numeral tells me the charge, so I don't literally have to look it up. So it is +3. And then oxide comes from oxygen. And again, I don't have to look that up. And if you don't know the charge of oxygen, just go, or oxidation state, whatever, you're going to look at the periodic table, and it is -2. Well, in order to form a compound, I have to have charges that end up equaling 0. So if I add +3 and -2, I do not get 0. So this is an incorrect as it is. So add another chromium, right? So that will give me a +3 and a +3, which is a +6. And then I would have to add 2 more oxygens, right? Because -2, -2, and -2 does give me -6. So how many chromiums did I need? 2. And how many oxygens? 3. Okay. Given the balanced equation representing a reaction, what is the mass of KCl produced when 24.51 grams of KClO3 reacts completely to produce 9.60 grams of oxygen? Well, this seems like it is a hard question, but I promise you this is actually way easier than you might even think. So it says we have 24.51 grams of KClO3. And then on the other side, we want to know how much KCl, but we know that we have 9.60 grams of oxygen. Well, what you need to remember is literally conservation of mass. So if we start with this many grams, we have to end with that many grams. And if these are the only two things that can give us those grams, that means whatever we had for oxygen has to add up, with the amount for KCl, has to add up to 24.51. So first of all, I can eliminate some options. Really can't be more. All right. And just logically, I don't even have to pull out the calculator. In order to get 24.51, I'm going to need to add this to 9.60, right? All right, which equation represents a conservation of atoms? So that means I have the same number and type of atoms on both sides. 1Ti, 1Ti. 4Al, because 2 times 2. Oh, okay, so this one's wrong. Let's go to the next one. 1Ti, 1Ti. 2 O's. 2 times 3 is 6 O's. Okay, wrong. 3 Ti's. 3 Ti's. 3 times 2 is 6 O's. 2 times 3 is 6 O's. 2 AL, uh-oh, 2 times 2, nope. All right, this last one better be right. 3 TIs, 3 TIs. 2 times 3 is 6 O's, 2 times 3 is 6 O's, and 4 AL, and 2 times 2 is 4 AL. Yep, there we go. 1 mole of bromine gas has a mass of. Okay, so I need to go to the periodic table. Here is bromine, and can you see its mass? 79.9. Okay, so 79.9 grams. That is the molar mass from the periodic table. But look at this, Br2. So I need to double this because this is for 1 bromine atom. So this is going to be our correct answer. Literally, it's the only one bigger than 79.9. All right. Given the equation representing a reaction, which type of reaction does this equation represent? Well, we started with one thing and we broke it apart. So that is decomposition. Which statement describes the charge and radius of the magnesium ion formed when a magnesium atom loses 2 electrons? I can get some help from the periodic table, and you see that magnesium ion has a +2, right? So the magnesium ion is positive. So I can eliminate negative because losing, all right, is going to end up with a positive charge. So the magnesium ion is positive, and is it radius larger or smaller? Well, if it's losing electrons, it gets smaller, all right? An oxide ion has the same electron configuration as an atom of which noble gas? All right, so let's find oxygen right here. And if it has a -2 oxidation state or charge, that means it gained 2 electrons. So it had 8 as an atom, but it gained 2, so now it has 10. What else has 10? Oh, look, neon. What is the vapor pressure of propanone at 45 degrees Celsius? Reference table question. So I need, here we go. So I need, what is the vapor pressure of propanone at 45 degrees Celsius? So see, vapor pressure. Okay, propanone, you see right here, it's this line. So 45, 25, 30, 35, 40, 45. Go up from 45, go across, and what's that going to be? Notice different scale. So we're counting by tens here, so it's about 70. Here we go. And now, based on table G, what is the mass of KCl that must be dissolved in 200 grams of water at 10 degrees Celsius to make a saturated solution? Okay, this one is a lot, so let's go to table G. All right, so probably going to have to zoom out a little bit. All right, so here's table G. What substance do I need? KCl. So, oh, luckily it's right here, so I can have enough. There we go, a little easier to see. So KCl is what I'm looking at. And what temperature did I want? 10 degrees Celsius. All right. And I'm going to go up. You just have to be careful because there's a lot of lines. All right. Now right here. All right. So what I need to be careful of, so we'll say at 10 degrees Celsius, right? I need 30 grams. But look at this. That's if I have 100 grams of water, right? But I don't have 100 grams of water. How much do I have? 200. So I could set up a, a proportion and make this be 200, but you should realize if I double the amount of water, right, I need to double the amount of grams. So remember, saturated means it's on the line, and you have to be careful to pay attention to how many grams they give you. In this case, I had to double the amount. Based on table I, which chemical equation represents a reaction with a heat of reaction that indicates a net release of energy. Okay, that was really super weirdly worded. Okay, so first I know I need to look at table I. So let's just get there. Okay, here we go, table I. A net release of energy. XO. Okay, let's go down here. A minus sign indicates XO. So I'm going to be looking for a minus sign. And here are my reactions. Either I'm starting with carbon or I'm starting with N2. So, and I am forming nitrogen or carbon compounds. All right, so here's the carbon ones, right? And for the nitrogen ones, they are up here. Okay, so what was I forming? I was forming C2H6 or C2H4. So, okay, so not this one. So let's look across at all of these. And there we go. There's only one. The one that forms C2H6 is exothermic. And even if you weren't sure, how about you just look them all up, and 3 are going to be positive and 1 is going to be negative. It's the process of elimination. The greatest increase in entropy, which is disorder. All right, so entropy, remember, is disorder. Okay. And when we have a solid, is the most ordered. Okay, so lowest entropy. And then a gas is the least ordered, highest entropy. All right. So if the entropy is increasing, I need to be moving toward a gas. And look, there's one that ends in a gas. That's perfect. Which particle diagram represents one substance only? Well, if it is one substance, it could either be one element or one compound. But if you look, this has 2 different things, 2 different things, 2 different things. This is the only one. Based on table J, atoms of which metal will lose electrons to calcium ions? All right. So let's go to table J. Here we are. And we had drawn pictures in class, right? So let's pretend this is the metal strip. Okay, which has atoms on it. And then we have a calcium ion, right? And what we need is something to go this way, right? To come off of the strip and swap places. So if here's where calcium is, the only thing that can do that is something higher. But let's just look them all up. Watch this. Aluminum. Where's aluminum compared to calcium? Right here. Lead, nickel, and potassium. So potassium, nickel, lead. So again, this is one of these things is not like the others, right? Here's calcium. The only one above it is potassium. Which aqueous solution is the best conductor of an electrical current? Well, we are looking at concentration for this one. And we have more ions, better conductor. So the highest concentration. There we go. And given this, the equation representing a reaction, this represents, look at this, 2 little bitty ones forming a little bit bigger. That is fusion. Which formula represents 2-butene? Well, first of all, I need a double bond. So how do I know I need a double bond? Well, you could use the reference table if you don't remember it. But here we go. You can see alkenes, right, need double bonds. I don't have to worry about that it's 4 because bute is 4 because literally all of these options had 4 C's. So 2-butene means the lowest carbon number it is attached to is a 2. So 1, 2, 1. See how this is carbon number 1? This bond is attached to that carbon. So it would be 1-butene. So there's 2-butene. And given this formula, which is an isomer. Isomer means it has the same exact atoms, just arranged differently, but it has to have the same number of atoms. Okay, so I need 3 carbons. They all have 3 carbons. 1 oxygen. Okay, I can get rid of this option that has 2 oxygens. And then I need 8 hydrogens. Okay, this only has 6. This only has 6. So there we go, isomer. All right, that is the end of the multiple choice. You can see how the second part of the multiple choice got a little bit more complicated with what you had to do, a little bit more steps. All right, now we are on to B2, and B2 has the easier written questions. All right, and B2 and C use the answer booklet. Okay, so when you get to this part, you fill out the top, and then here we go. Here's the space. So you can tell this is just going to be a short answer. This, they expect a little more, but you do not need to use all the lines. All right, let's go back to the question. So explain in terms of neutrons and protons. What does that mean? My answer must include the word neutrons and must include the word protons. Why? P32 and P31 are different isotopes of phosphorus. Okay, so let's go here and let's write our answer. Okay, so P31, P31 and P32 are isotopes of phosphorus, okay, because they have the same number of protons but a different number of neutrons, right? We had to mention both protons and neutrons. Another acceptable answer, not written out, same number of protons and different number of neutrons. That's acceptable, not as a whole sentence. Or you could make a simpler sentence, right? Both of them have the same number of protons, but a different number of neutrons, right? So you do not write all of them, you write one. So this one, this one, this one, all 3 get you full credit, okay? All right, determine the oxidation state of chromium in this compound. All right, so if we go to the periodic table and we see chromium, it has 3 options listed on the periodic table, but remember those are selected oxidation states, so that does not mean all of them, okay? So I have K2CrO4. There is no charge up here. So how I would solve this, if I was writing a simple algebraic expression, would be 2 potassium oxidation states plus 1 chromium oxidation state plus 4 oxygen oxidation states equals 0. If I'm solving for chromium, I must know the other 2. So potassium is +1 and oxygen is -2. So I'm going to plug those values in. So that was +1. Chromium is what I'm solving for. 4 times -2. All has to equal 0. So that's 2 plus chromium plus -8. Oops. -8 equals 0. Now, if you have math sense, you might realize what the answer is already, but I'm going to combine like terms, and I'm going to get chromium plus -6 equals 0. I'm going to add 6 to both sides. So just visually show you what I'm doing. I'm going to add 6 to this side and then add 6 to this side. So chromium equals plus 6. So on the answer booklet, right, I am going to write plus 6. What else is acceptable? Basically nothing else unless you wrote 6 plus. That's it. One of those answers or it's wrong. All right, so again, remember I said for chemistry exams, we're going to skip the reading, go to the questions because I may not even need the information. So let's go. State the general trend in atomic radius as these 4 elements. Okay, well, I need to look at which 4 elements. Okay, these are the 4 elements I'm talking about. Okay, are considered in order of increasing atomic number. So atomic radius is on table S, and I need to look at carbon, silicon, germanium, and tin. All right, so let's go to table S. Atomic radius is the last one, so carbon and silicon, germanium, silicon, right? Germanium. So let's see what we got going on so far. Okay, so we have 75 to 114 to 120. So what is the general trend that is happening? Okay, the atomic radius increases. Okay, that's an acceptable answer. What else could you say? As atomic number increases, the atomic radius increases. What else could you say? Down a group, atomic radius increases. What else could you say? Atomic radius increases down a group, or something similar. Do I want you to write all 4 of those answers? Absolutely not. Pick one. This answer, or this answer, or this answer, or this answer, or something like that. All right. We have one more question on the front here, 54. State in terms of electron configuration. So we have to talk about the electron configuration, right? Why silicon and germanium both form tetrachloride compounds. Well, if you don't know, tetra means 4. But actually you didn't have to know that because look, silicon tetrachloride and germanium tetrachloride. I give you that up here. So let's look at on the periodic table. Here's silicon, here's germanium. Look at their electron configuration and you see that they both have 4 valence electrons. So we go here, silicon and germanium both have 4 valence electrons. What is also acceptable? Silicon and germanium have the same number of electrons in the outermost shell. If you don't want to say valence electrons. Again, not writing both one or the other. Okay. Now let's look at this. 55 through 57. Again, we are going to skip to the questions because maybe I don't even need to read. So explain in terms of distribution of charge, okay, why a molecule of compound 1 is polar. Okay, so here's compound 1, right? But I don't necessarily need to talk about the specific elements. I just have to talk about how the charge is distributed. Okay, so the molecule is polar because it does not have a symmetrical distribution of charge. Okay, I have to talk about the molecule. We're not talking specific bonds, right? So the molecule has an uneven distribution of charge. okay? But one of those is going to be the kind of the key answer. So it does not have a symmetrical distribution of charge, or the molecule has an uneven distribution of charge. But notice how I talked about distribution of charge. That's how I'm going to get credit, okay? Draw a Lewis electron dot diagram for a molecule of compound 2. All right, so here we go. This is compound 2. And let's draw the Lewis electron dot. Now they give you a lot of space, right? No lines. So up here, I'm just going to write what I start with. H has 1 valence electron, right? And Cl over here has 7. So it's going to be Cl with 1, 2, 3, 4, 5, 6, 7. Now I need to put them together into a molecule. So I'm going to take H and I'm going to bond it to Cl. And that took care of this and this electron. So what I need to do is draw the already paired electrons around chlorine. Okay, so I'm just going to thicken this up so I can make the dots a little easier. All right, so 1, 2. Look at that. Okay, so why does that work? Because each of the elements, like chlorine, needs 8 around it. So if we count them, 1, 2 on the top, 3, 4 on the side, 5, 6 across the bottom, and then 2 in this bond makes 8. Hydrogen only needs 2, so it is done. There we go. There's Lewis dot. Okay. And let's see, 57. Here we go. Identify the 2 types of chemical bonds in the product of this reaction. So here's the product. What do we notice? If I go back to the reference tables and I go right here, here is ammonium. It is on table E. What do I know? These are non-metal bonded to non-metal. That's covalent, but it has a charge. So when it bonded to Cl, it made it ionic. So the answer is going to be both covalent, so covalent, and ionic. Okay, there you go. That's the 2 kinds of bonds. All right, I'm almost done with B2, but here we go, 58 through 60. So again, go to the question first, skip the reading, use it if you need to. State in terms of the average distance between the helium atoms. So average distance is key. Why the density of the gas increases. So you don't have to guess what happens to the density, they literally told you. Why does the density increase when the piston is pushed further into the cylinder? So let me just draw a quick sketch of what they're talking about. So here's a piston and a cylinder, and here is the piston pushed further, right? So if I have 6 gas molecules here in this same space, I would still have 6 gas molecules. So what happened to the average distance? Okay, so the average distance decreases when the piston is pushed further in, okay? The average distance decreases. Another answer you could write, because the volume decreases. You could say the atoms have less average distance between them. Okay, any one of those. Again, just to keep saying it, one or this one or this one, not all of them. All right, now this one, they gave me units. I'm gonna have to write an answer here. Okay, so let's look. Determine the volume of the helium gas when the pressure is increased to 1.5 atmospheres and the temperature remains at 25. Oh, you know what this is. I hope you recognize it. It is right here, combined gas law formula. All right, so it is P1 V1 over T1, right, equals P2 V2 over T2. But it says the temperature remains at 25. So first, what you should remember is temperature always has to be in Kelvin. But since the temperature is constant, I can just cross it out. All right, so that makes my life a little easier, and my formula just becomes, let me just write it over here, P1 V1 equals P2 V2. Okay, so let me just, okay. So it says the pressure is increased to 1.5. That is going to be P2. But where am I going to find P1 and V1? Up here in the reading up here. All right, so now I need to go up here. The volume is this. The pressure is this. So that's for 1. So what was P1? 0.500. What was V1? 300 equals, all right, what is P2? 1.50, and that's times V2. All right, what do? Multiply these two together. So you're going to do, and just make this a little easier to move around here. Okay. You're going to do 0.5 times 300. That's half of 300. Should be 150. Oops. I guess I didn't put it right. 0.5 times 300. I guess if I do 0 plus 300, that is 300. And I was right. So it is 150 on that side equals 1.50 times V2. How do I get V2 by itself? I need to divide both sides by 1.5, right? Divided by 1.5. So I go back to 150, and I'm going to divide it by 1.5, and I get 100. So V2 equals 100. And was it in milliliters? Yes. So ml. Now, does this make sense? It started with a big volume and a low pressure, and I increased the pressure. Yeah, it makes sense. It should be less volume, and it was. So I just have to put my answer here of 100. It does not mention significant figures, so that's it. I just write what I got in the calculator. I don't have to think about it. Compare the number. So here's the thing. When it says compare the number, it's either going to be 1 is greater, 1 is less, or they are the same. All right, that's going to be the answer. So compare the number of helium atoms in the cylinder at a pressure of 0.500 atmospheres to the number of helium atoms in the cylinder when the pressure is increased to 1.50 atmospheres by pushing the piston in. Well, I left the container closed, so this is an easy one. The number of atoms is the same, right? I could just write equal the same. The number of helium atoms is the same at both pressures. Sample answers, right? But again, 1. So this one, or this one, or this one, or this one. But just one of those answers. All right. Now let's go. This is the last little section of B2. All right. So 61 and 62. Again, skip the reading, although I'm probably going to need it because it looks like I've got numbers. But explain in terms of ions. Okay. So ions has to be a word in my answer. Why the hydrochloric acid solution can conduct an electric current. All right, so let's go to hydrochloric acid. Look, it's aqueous, right? So why can it conduct electricity? Okay, because when hydrochloric acid is dissolved in water, the ions can move and conduct electricity. What else could you say? The ions in the solution move freely. What else could you say? The ions are mobile in the water solution. Those are some sample answers. Again, one of these, not all of them. Okay. Determine the concentration of HCl solution using the titration data. So titration formula is right here. MAVA equals MBVB. So what is the acid? Hydrochloric acid. What is the base? NaOH. Okay. So it says a student places, so let's just, even though I'm not going to be able to write them as subscripts, I think it'll be a little easier to read this way. So MA, I'm going to write them as lowercase, VA equals MBVB. Okay. So it says the unknown concentration of acid and the volume of the acid is 21.0 equals the molarity of the base. I see that 0.125 and the volume of the base is 18.5. Okay. So I'm going to have this side, because that's just 21, equals 0.125 times 18.5. Okay, so 0.125 times 18.5 equals 2.3125. Okay, 2.3125. Now I'm going to need to divide both sides by 21, right? Divided by 21. Okay, it's 0.11011. Okay, so MA equals 0.110. Let me just write it down again. 119. Okay. 119 molar. All right. It doesn't say significant figure, so I could literally write that. Okay. But I am going to round this to 0.11. Okay. If I was rounding based on these significant figures, it would be 0.110. So let's write that one. Okay. 0.110. And they already put the units, so that's it. I'm done. Okay. If you want to know on the exam, it said you could have any value between 0.11 and 0.11012. As long as your number fell in between that, you are okay. Does not say how many significant figures at all. Those are acceptable. Okay. For number 63, here we are at the last part of B2. Determine the pH of sample 2. All right, well, I have to look at the table, right? So let's look. When the concentration is 1 times 10 to the negative 1, the pH is 1. When it's 1 times 10 to the negative 7, the pH is 7. When it's 1 times 10 to the negative 12, so what do you think the pH of sample 2 is? 2, right? 2. Other acceptable answer would be 2 or 2.0. Okay, so it didn't say you had to write a number. All right. All right, the last two questions for B2. Identify the ion released by the compound dissolved in sample 4 that allows the compound to be classified as an Arrhenius base. Okay, so what do Arrhenius bases have as their ion? Well, I could say OH negative, okay, ion, right, because it says, or I could say hydroxide ion. And if you forgot the name of that ion, we do have that available in table E right here. You should know Arrhenius bases, right, have OH negatives, and Arrhenius acids have H pluses. And then state how many times greater the hydronium ion concentration is in sample 4 than in sample 5. Well, from sample 4 to sample 5, the pH went up by 1, and every space on the pH number line, when you move one space, it changes times 10. So my acceptable answer could be 10 times, or it could just be 10, or the word 10, or tenfold. Okay, those would all be acceptable answers, but one, not writing a whole ton. All right, and that is the end of B2. All right, we are on to part C, the last section of the exam. This section would have the hardest written questions. All right, but again, I'm going to be consistent and skip the reading and go to the question. So it says, explain why the formula for tetraboric acid is an empirical formula. So here, right here, tetraboric acid, right? Why is that an empirical formula? Okay, well, it is an empirical formula because look at the subscripts. Can it be further reduced? No, it cannot, right? So it is an empirical formula because it cannot be reduced. All right, that should just say formula, or we could say the formula is in the simplest whole number ratio for all the elements in the compound. All right, again, a little bit, you know, more involved in thinking, but again, one of those answers is appropriate. All right, let's go to 67. Determine the number of moles of boric acid that react in the equation to produce 10 moles of water. Okay, so this is just a mole ratio question. So I want to produce 10 moles. Let me actually type it. I want to produce 10 moles of water, right? And I'm using boric acid. All right, so 10 moles of water. And that is going to equal, I need to use moles of water on the other side, okay? And then I am going to draw a line. This is going to be over, and this is going to be over. And on this side, what am I comparing it to? Boric acid. So boric acid. So how many moles of boric acid? Well, on this side, I get the moles from the balanced equation. And what am I going to look for? Coefficients. All right. So what is the coefficient in front of water? 5. So on this side, I'm going to say it equals 5 moles of water, right? And for the bottom of the equation, what is the coefficient in front of boric acid? 4 moles boric acid. All right. So what do? Well, I cross multiply. I do 10 times 4 and this. So what am I going to get? I'm going to get 10 times 4 equals 5 times my question mark, or I can just say x. What's 10 times 4? That's 40 equals 5x. Divide both sides by 5, 8 equals x. So my answer over here is 8 moles. What would also be acceptable? 8.0, right? 8. Since I have units here, I'm going to be expected to write a number. All right, now 68, I can tell it's got some space. So I'm drawing something, I'm solving something, I'm setting something up. So show a numerical setup for calculating the mass in grams of a 0.200 mole sample of borax. Okay, so I need a formula from the reference table, right? This is the formula for mole calculations. So moles equals mass over, right, over what? Gram formula mass. Plug in what we know. So we know 0.200 is moles, right? It says we're calculating mass. So I'll just say G because that's the unit for mass, right? And that is going to be over on this side, the gram formula mass. Whew. Well, let's see. If I go up here, do I have to calculate it? Okay, so it's borax. Oh, look at this. Beautiful. The gram formula mass. Oh, I love it. I don't even have to calculate it. Over 381. And hold up. It says, show a numerical setup. So this is the answer. I'm done. I do not have to solve for anything. I don't even have to put units. All right, so I go back here, and what I need to write is 0.2000, right, equals, and that was grams on the top, right, over, and what was the gram formula mass? 381 over 381. That's it. Finished. Done. You don't have to cross multiply. You don't have to do anything. That's it. If it says show a correct numerical setup, choose the right formula, put the numbers in, and stop. Okay. Next set. So again, skip. Oh my goodness, a lot. And go to the question. So we're on question number 69. And it says, state the number of significant figures used to express the value for the mass of the water in the can. So here is the mass of the water in the can. How many significant figures? Well, you see the decimal point. That means we start from which side? This side, right? This is not a 0, so it all counts. So it's just 3. Now I could write 3. That would be acceptable, but that's it. Those are the only correct answers. All right. State the direction of heat flow. And we're not going to say left, right, north, south. No. Between the air and the water in the can. Okay, so what is the temperature of the water in the can and what is the temperature of the air? So now I'm going to need to go back up here and I'm going to scan. So I see right here the air temperature is this and the starting temperature of the water is this. So what is happening? The direction of heat flow will go from, well, it goes from warmer to colder. So the air is warmer than the water. Okay. So it will go from the air to the water. That's it. Okay. And determine the amount of heat absorbed by the water. Okay. All right, so I need a formula, right? So I'm going to have to go here, and here are my heat formulas. The temperature is changing, so this is the only one that is going to apply. So I need Q equals MC delta T, right? So let's write this out. Q equals, now it says that heat absorbed by the water, so I need the mass of the water, that's 190. I need the specific heat capacity, that's what C stands for. That's from the reference table. So I go all the way to the front, and there is the specific heat capacity, 4.18 and I need the change in temperature. Well, look at this. It said calculated temperature change of the water. So it gave me that. I didn't even have to do the math. So now I just need to pull up the calculator, and I need to do 190 times 4.18 times 39 equals. So my answer is 30,973.8. So 30,973.8. Okay, let's just make sure I wrote it down correctly, right? So that is Q. And that's joules, right? Now I can write it just like that. It does not say I need a certain number of significant figures. If I was looking for significant figures, I would only want 2 because almost all those have 2. And so that's the lowest number of significant figures. So to 2 significant figures, it would be 31,000 joules. But again, it does not say I need significant figures. So you can literally just write this straight from the calculator. Okay. So 31,000 joules is my answer here. Want to know what they're allowing, accepting? Anything from 30,700 joules to 31,122 joules. As long as your answer is in between those, you get credit. Okay? All right, next set, 72 through 76. Again, skip the reading, go down here. State evidence from the equation. So here's the equation. The answer has to be in the equation, okay? That the forward reaction is exothermic. All right, so this right here, okay? Energy is what? Energy is a product. What else? Heat is on the right side of the equation. Almost forgot which side was which. What else could you say? The 91.8 kilojoules of energy is a product. Those are 3 acceptable answers. Okay. What else? Compare. So again, what are your answers when it says compare? So one is going to be greater, one is going to be less, or they're going to be the same. Those are really the only possible answers. As long as I say, I have to identify which things I'm comparing. I can't just write greater, less, or the same. I have to say, in this case, forward reaction and reverse reaction. All right, so compare the rate of the forward reaction to the rate of the reverse reaction at equilibrium. Okay, so at equilibrium, the rates are equal. Oops. The rates are the same. The rate of the forward reaction equals the rate of the reverse reaction. Again, 3 acceptable answers. Please don't write them all. Choose one. All right, for number 74. On the labeled axes in your answer booklet, draw a potential energy diagram for the forward reaction represented in this equation. Well, we already determined that the forward reaction was what? Exothermic. So all we have to do is draw an exothermic potential energy diagram. So we start with reactants, have some activation energy go up to the activated complex, and our products must be lower than our reactants. Voila. Did not have to look exactly like that as long as we have reactants right here, activated complex goes up, and that the products are lower than the reactants. As long as yours fits those requirements, then you get credit. All right, so now 75. State in terms of moles of gas. So again, my answer has to say moles of gas. All right. Why the equilibrium shifts to the right due to an increase in pressure. All right, so it tells me that it shifts this way when I increase pressure. Why? Okay, well, this is a gas. How many moles? 1. This is a gas, how many moles? 3. This is a gas, how many moles? 2. So on this side of the equation, I have 4 moles of gas, and on this side of the equation, I have 2, because this is not a gas. So why does the equilibrium shift to the right when you increase the pressure? The product side has less moles of gas. Right? That's one, has less moles of gas. Okay? You could say there are more moles of gas on the left side of the equation. You could say the reactant side has 4 moles of gas and the product side has 2 moles of gas. All right, so in some way I had to talk about moles of gas. Again, 3 acceptable answers. Please don't write 3, write 1. All right, 76. State what happens to the rate of the forward reaction when iron is added to the system. Okay, so where is iron? Oh, it says right here. I don't see iron in the equation, so you're like, ah, well, it's right here. Iron can be used as a catalyst. So what does a catalyst do? It increases the rate of the reaction. So the rate increases when iron is added. I could say the rate of the forward reaction increases. Okay, I could say adding iron increases the rate of the forward reaction. 3 acceptable answers. Again, pick one. Number 77 is in my next set. Identify the element present in urea that is present in all organic compounds. Well, you should know that. Boom. That's an easy question. That was like a gift, wrapped up in a bow and everything. Number 78. Compare the formula mass of the 2 compounds in the equation. Okay, well, now I could calculate the formula mass, but what I'm going to do is see what elements we have. So I have this, and it has 1, 2 nitrogens. This has 1, 2 nitrogens. Okay. This has 4 hydrogens. This has 2, and 2 is 4 hydrogens. This has 1 oxygen, and this has 1 oxygen. And this has 1 carbon and 1 carbon. Oh, that's it. It counts for everything. So if they have the same number and type of elements, the formula mass is going to be equal. So the formula masses are equal. All right. Both compounds will have the same formula mass. Okay. They both have the same formula mass. Slightly worded differently, but again, pick one way to write your answer. And last one for this section, 79, state in terms of molecular polarity. So I've got to talk about polarity due to a molecule. Why urea is very soluble in water. Well, think about what dissolves in water. Anything that's polar or anything that's ionic, it's got to have a charge. This is not ionic, so why must it dissolve in water? Okay, because both urea and water are polar, so urea dissolves in water. Okay, I could just say urea is polar. All right, I could say urea dissolves in water because they have similar polarities. All right, 3 versions. You only have to write one. All right, now let's go here, 80 to 81. Oh, beautiful. I love these questions. So what I recommend doing is, before I even get to the questions for this one, I love a good diagram. I'm going to draw some stuff. Now it says it's a voltaic cell, so I already know what's happening. In a voltaic cell, I have chemical energy creating electrical energy, all right? So let's find these two elements on table J. So let's get to table J. And what two do we have? We have zinc and copper. So here's zinc and here's copper. Which one is higher? Zinc. So that means zinc is negative, copper is positive. Since this is voltaic, the higher one is the anode, right? So this is the anode. All right, let me type now. All right, which means because of anox, this is where oxidation occurs, which means it's losing electrons. And on this side, this is the cathode, which is red cat. Reduction is occurring here. It is gaining electrons. And because of fat cat, this gets bigger. When it gets bigger, it means more atoms, less ions. All right, what else do I know? Electrons move through the wire from anode to cathode. And I know that ions move through the salt bridge in both directions to keep the cell neutral. Okay, so then it gives me some voltages here. And it says, based on the graph, determine the voltage of the cell if the copper concentration is 1.5 molar. Okay, so I literally just have to read the graph, right? So here's 1.5 molar for the concentration. I have a point there. So now I need to go over here and estimate, right? So it needs to be between 1.10 and 1.11. And I don't know, it kind of looks maybe halfway. So I just have to be careful because I need to write 1.10 and then estimate. Okay, so my answer is going to be 1.10, like 5, if I say it's halfway. What does Regents accept for this question? 1.102 all the way to 1.108. So you had a lot of flexibility on that one. All right. Write a balanced half reaction equation for the oxidation of zinc that occurs in this operating cell. Oh man, there's only 2 questions and then it was half reaction. All right. So it says zinc, right? So I'm going to pull the zinc pieces out of the equation. All right. So I'm going to get, let me type the part and then I'll write the charge because it's too hard to do. I can't do exponents with this. So zinc yields zinc, and then I'm going to write 2 plus because it should be a subscript. This is not a half reaction yet. I need to have electrons, right? Now it told me it was oxidation, but I knew that because I labeled this here, right? When is oxidation? We lose electrons. So if you remember when we drew the number lines, and this was Leo up here, and this way was Ger pointing toward the reactant side. So electrons go on this side. How many electrons? Well, from 0 to +2. Oops, that was a terrible 2. Let's type it. +2 electrons. So that is the whole equation. So let's transfer that over here for 81. Zinc yields Zn. I'm going to leave some space so I can put the charge in, but again, since I can't do subscripts, I don't want it to look wrong. Like this. And electron, like that. So zinc yields zinc with a 2+ charge and 2 electrons. Okay. If you do not write the negative for the electrons, it is wrong. So do not forget this. Okay. All right, this is it. Last question. Again, skip the reading, go down here. State the neutron to proton ratio for an atom of the 58 iron isotope in equation 1. Okay, so neutron to proton. So how many protons are in this one? Well, it says 26, right? How many neutrons are there? Well, I need to do math. So I have to do 58 minus 26. What does that equal? 32. So the ratio of neutrons, which was 32, to protons is 26. So 32 to 26. That is the ratio. I can reduce it because I can divide both of those by 2, which is going to be 16 to 13. All right, so my answer for 82 is going to be 16 to 13. Okay, or 16 to 13. All right. But for this exam, they are giving you credit for 32 to 26 or 32 to 26. You could also have written it like this, 32, 26, like this, 32 over 26, or 16 over 13. All of those are acceptable. Had a bunch of answers. Just had to have the right numbers. All right, 83. State in terms of elements. So I got to talk about elements. Why equation 2 represents a transmutation reaction. Okay, so let's look at equation 2. We started with what element? Iron, and we ended with cobalt. Okay, so why is it transmutation? All right, so it is transmutation because an element of iron is changed to an element of cobalt. All right, or you could just say one element is changed into a different element. Okay, you could say the element on the reactant side changes into a different element on the product side. Okay, 3 possible, you write 1. Almost there, 2 questions left. Identify the particle represented by X in equation 3. So we got to figure out what's missing. So on this side, I just have one thing. So it needs to equal 60 on the top, and I only have 59, so I'm missing a 1 on the top. I need 27 on the bottom. I already have 27, so I need a 0. And then I go to the reference table. Well, reference table, I go to O, and what has a 1 on the top and a 0 on the bottom? Neutron. So I write 1 on the top, 0 on the bottom, and this. What is also acceptable? To write neutron. That was acceptable. One last question. Determine the fraction of an original sample of cobalt-60 that remains unchanged after 15.813 years. Okay, so when I start with 1 whole, right? Then I have a half left after 1 half-life. After 2 half-lives, I have a quarter. After 3 half-lives, I have an eighth. After 4 half-lives, I have a 16th, and it would continue. But let's look up cobalt-60. Where do I go? Table N. So here we go. Cobalt-60 has a half-life of 5.271 years. Okay, so let's write this down. So 5.271 years. So that means every half-life here is 5.271 years. And this one is 5.271 years. And this one is 5.271 years. And this one is 5.271 years. So how many years passed? 15. So I need this half-life and this half-life and this one. That's it. So not this. So what fraction is left? 1/8. Okay, so what fraction is left? 1/8. All right, now you could have written 1/8. They also accepted 0.125, which is dividing 1 by 8, or changing that into a percent. So those are all acceptable for this exam. And that's it. You made it. This is the most recent exam so far, and it made it all the way through. Good luck on your exam.